The next is your controlled access protocol. Uh, since it is written that it is controlled access, this means that the mechanism is all about means superiority, priority based. Something is controlling, right, and some devices are being controlled. So here you can see the first one is a reservation, right? Since it is saying that it allows only one node to send at a time, right? So when only one device is sending the data in a particular time, so there will be no collision. Will be avoidance of collision, right? So number one is reservation. In reservation, it is like you need to reserve the reserve slots or reserve frames for sending the data. The device has to reserve before it sends its data, without reservation it's not possible to use that medium. It's just like when you go for a dinner or lunch to some restaurant. So you first reserve a table for yourself. So it is the same. If you don't reserve a table for yourself, so there will be no reservation for you. If there's no reservation, you cannot go there and have your dinner, right? It is just like if you need to go for a checkup to a doctor, you need an appointment. Without appointment, you cannot reach there, right? It's similar like that. It's an irrelevant example, but I want you to understand that this. Uh, this is why I'm making you understand it like that. So it's not necessary that you give me such type of example in papers, but just to keep this thing in your mind, I'm giving you this type of example. So it's like that. For sending the data station should reserve uh, first. So here you can see there's data station 4, 3, and 1. Now these data station have done reservation. You can see these slots at 1, 1, 1. It means that data station 1, data station 3, and 4 has done the reservation, so that they can send their data on their time. And 2 and 5 does not have any reservation. They have not reserved, so this means they cannot send the data. The data station that reserve first will send their data. Okay, it's like that. Now uh, so this is all about the reservation control access protocol. Next we have polling. Okay, polling, or you can say select and poll. In this one, it's like there is a primary device which has the control, and there are many secondary device. Okay, so when the primary device needs to send the data to the secondary device, the mechanism is known as select. And when the secondary device needs to send the data to primary, so this is called the mechanism is called poll, right? It is similar like in a class there's a teacher. Okay, the teacher is the primary device, you can say. And I'm just giving you an example so that you can remember this thing. And in secondary devices are the students, right? If the teacher needs to send data, okay, for example, I need to send the data to any one of you, just like I need to send the data to your CR. So I can just select your CR. Okay, that I have to talk to you. Okay, the CR replies me back, yes ma'am, I'm here, you can talk to me. So I just give her or give him some information, right? And he or she will acknowledge me that yes, I have received that acknowledgement. Similar like that, in select, the primary device will select one of the devices amongst the secondary device. Okay, the secondary device, the device that has been selected will acknowledge that I am here, I'm ready to receive the data. Like this, there will be one-to-one communication means that there will be no collision because the primary device is only selecting the device. There is an address with that uh, data that this should be reached to this device, right? Now the data is will be sent and the secondary device will acknowledge that I have received the data. It's similar in this in it's somehow different because here now secondary device needs to send the data to primary device. So for this also, first primary device will poll any of the secondary device that either it needs to send the data or not. Okay. After polling, the device that has been polled to send the data will say yes or no. Either that device, that secondary device wants to send data or not. If it sends negative, NAC means negative acknowledgement. If it sends negative acknowledgement, this means this secondary device does not need to communicate with the primary device, does not need to send any data to primary device. Now the primary device, as you can see over here, it has pulled the another device that is B, another secondary device B, and it just sends the data. Okay, when it is told to send the data, it will send the data, and then the primary device will acknowledge that I have received the data. If you want to remember this, it is such like that the teacher can ask any of the student randomly that either you have any question to ask me or not, right? So if he wants to ask a question, he will say, yes, ma'am, I have a question. It will just ask him, and then the primary device will reply back that I have understood what question you need to ask, right? So this is how select and poll works, right? But if you see, if there is no data to be sent by any of the devices, so this all sending and receiving, this is all the wastage of channel. Now next we have token passing. uh, Token passing is in token passing there's a logical ring amongst the devices. Okay, and on that they are connected through a logical ring actually, and a token is moving around that ring with a small bit pattern. Okay, this token is a small bit pattern. So once this token is, if this token is moving uh, in this logical ring, okay, so there are many station. If any of the station needs to send data, it will grab this token. Okay, it will grab this token and sends the data. So as only the device which has this token can send the data, other devices cannot send the data. If this token, when the device has sent all the data, now there is no data to be sent by that device. So this device or station will release that token. Okay. So releasing that token means now that station will not send the data. Any of the other station that needs to send the data will grab that token and then send the data. So this is about the logical, token passing uh, control access protocol. So these three were the control access protocol. There was reservation, there was select and poll, and there was token passing. Okay. Now we have our last uh, you know the medium access protocol, and that is channelization. Okay, now in channelization, it's all about wireless means your bandwidth. What is bandwidth? Bandwidth is actually the ranges of frequency, right? Now uh, you have seen that what is medium access technique actually is that medium is being shared amongst the station, amongst the devices in a network, right? Now here your medium is uh, the medium in these protocol is actually uh, used in some other way rather than that of the previous ones. Okay, there's a channelization, mean your channel is divided considering frequency, time, and code. Okay, these three parameters are considered for division of the channel. Okay, so whenever there are many devices to access the channel, so that that bandwidth is already shared by the division of that bandwidth. Okay, so this division can be either in form of frequency, either in form of time, or either in form of code. Okay, now when we are doing FDMA, frequency division multiple access, this means your overall bandwidth is divided. Okay, it is divided and different ranges of frequencies are given to different devices. If you have understood the cellular system, over there we have understood this, that the different different cells have different frequencies. Okay, so this collision and all thing does not occur and all. So over there, these FDMA, TDMA, CDMA, these things are used. Okay, now in frequency division multiple access, your bandwidth is divided and each of the device is given the different bandwidth. Okay, and there are guard bands in between so that there should be no overlap. Then we have time division multiple access. In time division multiple access, the bandwidth is not divided amongst the all the devices. The bandwidth is same for all. The overall bandwidth that is available will be provided to all the devices. Okay, but it will be for at different time slots. Okay, not at the same time. When we were talking about frequency division multiplexing, it was given for all the time, but the frequency was divided. The overall bandwidth was not provided. But during the TDMA, the overall bandwidth is provided to all the devices, but at different times. Okay, now when we have come up to the code division multiple access, we have overall time, we have overall frequency. Okay, but the codes are given, right? Means CDMA is more efficient. CDMA is more efficient because the overall bandwidth, the overall time is provided. Just code is given to different devices. Did you understand this? Did you understand channelization? Yes, students.
Yes, miss.
What about others? Okay, let me.
Yes, ma'am.
जी क्या कह रहे हैं बेटा आप?
Yes, ma'am. कह रहे हैं मैम, समझ आ गई.
Can anyone of you explain it? Let me explain it in another way. Okay, for example, there is a classroom. Okay, there is a classroom and there are students in a classroom. Now I as a teacher ask you to make groups among your classmates, right? So I just request you that you should make 4 groups, for example, right? I'm just trying to make you understand this channelization more clearly. For example, I asked the students to make 4 groups, 4 different groups, in order to attend meetings in a classroom. Okay. Please reply me back so that I know that you people are understanding and you are there. So there are 4 groups in a classroom. Okay, now the classroom, you just take an example that your classroom is the overall bandwidth. Okay, the classroom is overall bandwidth, and those groups are the devices. Okay, so uh, uh, so I just ask you to use that classroom which is related to the bandwidth, now I say, and the groups are the devices. Now each of the group will attend is meeting in that class. Okay, so what will happen in the same class? What will happen if all the groups are attending their meeting at the same time in the same class? What do you think what happened? It will be possible for you people to clearly attend, efficiently attend the meetings in the class? Yes,
No,
student.
ma'am.
No. Why? Because there will be a chance of,
मैम नो
yes, because
मैम नॉइस वगैरह हो जाएगी.
yes, there will be collision of data. Okay, all the groups that are attending the meetings, it will be like that. You can listen to other groups also, right? And they can listen to you also. So there will be a collision. There will be misconception, right? So here what we do, we will do frequency division multiple access. Okay, your room was your bandwidth, classroom was your bandwidth. Now you have to do frequency division multiple access, means that you have to divide the bandwidth. You have divided your classroom into 4, corners. Understood? Now that 4 corners will, each corner will be for one of the groups to attend the meeting. Okay, so your bandwidth here has been divided. Each of the group has been given a small area. Okay, and that small area is the range of frequency. Okay, some part of that bandwidth. Now when we come to time division multiple access, I will ask the students that you should not attend your meeting in this way, that you are in the same class, means in the same bandwidth, right? And you have just divided your bandwidth, you have taken small areas of that class and you are attending your meetings. You should not do it like that. If you have 3 hours of the class, you should divide your times. Okay, we should have some time slots. We should give the first time to group A, and then they will complete their meeting. They will empty the class, then the second group will come, and when the second group has come, end up their meeting, the third group will come, and after third group, the fourth group. So like this, the overall bandwidth will be given to all the groups. Okay, understood this? The overall bandwidth is given to all the overall class has been provided to each of the group. Okay, first we just have a small area, each group had a small area, but now we have the overall class for each and every group, means the overall bandwidth is provided, so means it is more efficient. Time division multiple access is more efficient. Now when we come up to code division multiple access, now take the example like that. You have the overall class. Okay, the overall class you have, it's overall class you have, means you have the overall bandwidth. Okay, you have the overall bandwidth, and you have the overall time also. The time is not being divided, the frequency is not being divided. You have the all class, now you have the all bandwidth, right? But we have changed the languages of all the groups. Do you understand that? When we have changed the languages of all the group, it is like that one language is understood by one group, means the sender and receiver only understand that language. Okay, the sender and its receiver will understand the language. So like that, the data that is not for the receiver, that receiver will not will not be able to receive that because it does not understand the language. Understood this? So that
Yes,
language,
ma'am.
I'm giving the example, I'm relating that language as the code. Okay, so different uh, station will have different code with their data. Okay, and that code will be synced with its receiver. Only the sender and receiver will have that code. That means only that the sender will send the data only that will be received by the receiver. Okay, it will only be received by its own receiver because that code is between the sender and the receiver. No one else understand that code. Okay, so there will be a difference of language if you can make yourself understand it like that. So it will be a difference of language in a classroom amongst the different groups. So it will be easy to conduct their meeting in their own language, having the overall class and overall time. This means having the overall bandwidth, overall time. Okay, and all the groups are in the same class without the frequency distribution, without the time distribution. Okay, the overall thing is done through the code. Okay, students. Yes, please, did you understand this?
Yes, ma'am.
Any question? So do you have any question? No questions?